Hello, I'm going to see if I can do this in one take. This is the Project 4 color mixing lamp on Autodesk TinkerCAD. I'll be going between TinkerCAD and the Arduino editor. If you're wondering how to get this on TinkerCAD, what you want to do is you want to go up to Learn once you've logged in, switch this to Circuits, and then projects. Check out my other videos though. But if you click on show all Arduino, I do go through a lot of those. You'll see color mixing lamp is right here. So that's the one we're going to be working on. So let me get started. Now, the introduction, I feel like I don't really need to go through that with you. But I'm more than happy. It talks about how you're going to be creating a lamp that changes colors and all that. This is probably going to add an issue. Let me do something really quickly. Oh. All right. So I click on, nope, I don't. Oh, here we go. Okay. So then we move forward. In this project, you use a RGB, that's red, green, blue LED, and 3 photoresistors to create a lamp that smoothly changes colors to match the color of the external lighting conditions. Now you're more than welcome to, read through the rest of that. These are the things you need for it. You should read through that on your own, okay? And then I am going to move on to setting it up. So setting up the circuit, and this can be on this, or it can be in real life, right? They sell these kits. So setting up the circuit, the first thing that we want to do, and if we look, well, I'll get into that in a second. In every project, you wire your breadboard to connect the 5-volt and the ground pins. So we've got 5 volts down here. That's electricity coming out, and you want to wire that to the positive rail. Remember, the electricity goes the horizontal will always be positive then, and then if you connect anything here, it'll be negative. That should be red. Now, if you're setting this up in real life, the colors actually don't matter, but they help keep you organized. So like when I'm wiring my quadcopters and stuff, like the one behind me over here, I try to keep the colors all organized, because then it makes more sense. Just like I could, you could connect from here to here. It doesn't really matter, but keeping it organized, let's undo that. Keeping it organized, is always good. So connect the power and the ground rails on the breadboard to the power and ground pins. We got that. If you connected to the 3-volt, you'd only be receiving 3 volts. And in this case, they want 5 volts because that dictates what resistor we would need for our LED. All right. Connect the ground rail and the breadboard to each of the power rail. To each other, and the power rails to each other. So now what they want us to be able to connect positive here, but also positive up here. So we connect positive to positive, make that red because it's positive. Make the negative to the negative, make it black because it is negative or ground. And then we move forward. Adding photoresistors. So they want us to place 3 photoresistors on the breadboard in row G, blah, 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 blah. You can read the whole thing. That's fine with me. But you can also look here, and this is the best way to see it. Now, it's very important that we match our colors on our resistors, especially if you're doing this in real life, because you could burn your components out. So we're going to connect those together. So I'm going to grab it. It connects on 19, 23, and 27. So 19, 23, and 27. Now I know they're not the correct correct colors, but I want to make sure they're connected to the right one. We are going to the negative, and we want to make sure that they are the right colors. Now those colors correspond to how much resistance it has. And so if we look here, do they have the information on it? It is a 10K ohm resistor. So we click here, we change it to 10, and you'll notice the colors change, and now they should match what's on there. So if you are choosing a resistor and setting this up in real life, you would want to make sure that the colors are correct. And there are websites where you can look up what the colors mean, the order and all that stuff. All right, then we move forward, and we can just look at this, and we need a photoresistor. So we've got a photoresistor. Now we can scroll through here until we find our photoresistor, which it shows up right here under my picture. And remember, you'll notice it's going negative through the resistor. Then this connects to that side of the photoresistor. The electricity would travel through the photoresistor. Okay, it depends on how we want to actually look at it, from negative to positive or positive to negative. But in this case, let's just make sure we have a complete circuit. So we are going through there and then up to the positive. So that's nice and easy. So we know this would connect here, right? We know we would have another one connecting here and another one connecting here. Now I could have this here. It doesn't make a difference. It could be here. It really doesn't make a difference. We just need enough room to be able to connect other wires. And in this case, they wanted us to connect these to the analog in. And we'll get to that in a second. Let me connect these last ones. So we've got this to positive, make it red because it's positive. This to positive, make it red because it's positive. And there we go. So now all our reds mean it's positive. So what we've got, we have 5 volts coming out here, running through this entire rail, running up here, making it run through this entire rail. We have the 5 volts going through the photoresistor, which it changes its resistance depending on how much light it's seeing, right? Photoresistor. The resistance changes based on light. And then it'll flow to ground. However, that's just to make sure, I think, that it doesn't burn out, because then what we're doing is we're connecting. This analog pin is going to read how much electricity is flowing out of this side because it's a photoresistor. And depending on how much electricity is flowing out, it will tell us if there is more or less electricity. So if we look there, just to make it match, they've got this one running to 2, 1, 0. Now, the reason why we don't want this running to, and let me hook this up and then I'll tell you. The big reason why we're connecting to analog is because it's going to give us a range. If you're wondering how I'm changing getting rid of, if you make a mistake, just press Control Z, or you can do, Zulu, or you can hit back here. So the reason why it's going to analog is because what's going to happen is it's not going to be an exact value that with the amount of electricity coming out of this end of the photoresistor. It's going to be a range, and that's analog, because digital is only on, off, on, off. It can't read anything else, right? It's either on or off. It doesn't matter how much electricity is flowing into it. It's just on or it's off. So in this case, the analog in, it's going to be reading a value, and I can't remember. It's like 0 to 2056 or something. Maybe we'll see that as we move forward, but it'll read a value in between that, and it'll be able to read how much light this resistor is seeing, how much light this resistor is seeing, and how much light this resistor is seeing. So now if I look here, we've got everything wired up, everything we need, so we're all good. Let's make sure, finally, you can name each one of the photoresistors in the simulator so you can remember which sensor is associated to each color. That's a good idea. So to do this, highlight one sensor at a time with the cursor and rename it in the pop-out menu. Now, the thing is, right now, and maybe I missed it, and I don't want to read back through this, we don't know which one is which. So let's do that in a little bit, okay? That's probably going to have to do with coding later. So if we move forward, it says use the image as a guide, slip one of the wooden cutouts on the head of each photoresistor. So they want you to do this in real life. They want you to cover each one up. It says each of these filters lets only light of a specific wavelength through to the sensor it's covering. So that's a good thing. The red filter passes only red light. The green filter passes only green light. And the blue filter passes only blue light. So just think about those old 3D glasses, not the polarized ones that we use in theaters now, but the red and the blue. I think it was blue, yeah. Red and blue. You'd see mostly red through one side, mostly blue through the other side. And so that's what this is really setting up. So use the image as a guide. So place the red gel over the photoresistor connected to A0, analog 0. This is going to be the red one, okay? So now this is the time where we'd want to click on this, and it can actually have a name, and I'd say red, okay? And we'd put that over it. Now, I don't believe they actually have the filters. Let me check. Let's go to components. Maybe I'll just say filter. Yeah, I don't believe they actually have those filters, which is strange. Um, Maybe they call them gels. Oops. And hey, if you find it, and I'm incorrect, obviously I might be incorrect, comment. Comment down below. Okay, if you're watching this on YouTube, comment down below where we can find that. But in real life, we would cover those up and it would be able to identify the different color light because only red could get through here. Only this one connects to A1, so that would be green. So only green light can get through there. And on the last one, only blue light could get through that one. So that means if this resistor is showing that it's seeing a lot of light, we know that light is blue. If this is seeing no light, we know that it is not green and it is not red. And remember, right, we've got RGB, and we can make all the colors from red, green, and blue. And so depending on the mixture of outputs from these sensors, then the Arduino can figure out exactly what color is being shown to those photoresistors. So the LED with 4 legs is a common cathode. So let's look at our setup. Now what we've got, and that's interesting. I feel like I can't see that. Let me pull up here. So it says place the RGB LED. It's interesting. Let's search for RGB. Yeah, this is what it should look like in this picture. I don't know. Maybe yours will show up differently. I can't see it, but it's connected to 12 to 15. So we're going to grab this 12 to 15, and I'll talk about what those connections make. Now you can get schematics on these things. You could look up RGB LED, but you might need the company that made it. But if we'll see 12, those connect together. We're just connecting this rail to that rail, and this rail to that rail, that one to that. So those are called what? Hopefully you know already, but they're called resistors. And the reason why is we want to just make sure that not too much electricity is flowing through these components, because that would be bad for the component. It could burn it out. All right, and this is an LED. It's going to light up. So what we've got the 3 resistors. If we look, the colors, do they match? Red? No, they don't. And so we need to make sure we have the right resistors. And so if we look, use Arduino's post width modulation pins, which are connected to the anodes through 220 ohm resistors. So these should be 220 ohms. So we need to change that. Say 220 ohm. Let's see if the colors will match. I believe they do, so that's a good thing. Make sure it's ohms. You want to look up what those words, mega ohms and all that stuff, you can look them up. I'm not going to go through that in this video because I'll give you the wrong answer off the top of my head. All right, so we got our resistors, right? We know that limits the flow of voltage. Then we've got this pin is connected to the negative rail. So let's just connect that straight to the negative rail. We'll make it black because it is negative. We know that because it's connected to the negative rail. And then we look at the rest, and these 3 are connected to 11, 10, and 9. So we've got 11, 10, and 9. So it goes to 11, 10, and 9. You might hear my son crying. I'd help him, but my wife's got him. All right. Rough days for toddlers. All right, so what we got here is now these are putting out a specific amount of electricity to give a better understanding as to what light is coming out. The Arduino is reading. The Arduino is reading the values coming off these sensors, and then it is going to put out something. And I'd imagine, well, this is the ground, right? So for an LED, let's do this. Hopefully this makes sense to you. I think it'll totally make sense to you. I pressed the wrong one. Sorry about that. I meant to type LED. If we had a normal LED, okay, to get that to light up, we would have to connect one side. This is probably the wrong side, but one side to the negative, one side to the positive. Okay, and I'd change those colors if I was keeping it, but I'm not. Right now, there would be electricity flowing through, from here, voltage going through the LED, lighting it up, right? If we got rid of this wire, the electricity would have nowhere to go, so it's not going to flow through the LED. All right. This, and I'd imagine it's RGB in the order, but maybe I'm wrong. Oh, there it is. If we mouse over, it says this pin is to light it up red. This is a ground, the cathode, anode, cathode. This is blue and green. So if we have the cathode grounded, okay, so this is grounded, and we send electricity just through this one, it's going to be red. If we send electricity just through this one, it's going to be blue. And if we send electricity just through this one, it's going to be green. And if we send a little bit of electricity through here, it's going to be slightly green. And if we do it here, it'll be green and blue mixed and red mixed. Now, I did say these are digital, so it's only on or off. But there's this thing called post-width modulation. Basically, it's turning it on and off at a very high rate of speed. So it actually gives the illusion of it being analog output. So, for instance, if I had a light and I flashed it on and off very, very quickly, faster than your eye could see it flashing on and off, it would look like that light is dimmer than when it is on. And that's what it's doing. So, post-width modulation. All right, so now let's move forward. Hopefully that all makes sense. It's a pretty cool circuit set up there. And it's really cool when you're able to see it working. So then it gets into the code, and me, not a huge fan of how they've written the code in the past. And so what I'd really like to do is I'm going to go to the last one. I am going to show you, let's go to, now you could go through all those, and of course you're more than welcome to. But I'm going to show you the code straight from Arduino, and I'll walk you through it. So I'm going to go to the Arduino editor, and I found it by going into examples, and then all the way down at the bottom, starter kit, basic kit, color mixing lamp. And I'm going to take all this, I'm going to paste it in there. Now you can do that, but please, 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 go through this with me. Go through it with me so you understand it. Now, this always is just saying, hey, this is how we set it up. It talks about the basic setup. And it normally has a person's name. So thank you, Federico Vanzati, for these improvements and setting it up, and Scott Fitzgerald for the original one. This is awesome. So what they're saying is green LED pin is number 9. So if we look, 9 is going to be green. We can see that, yes, it is green. 10 is going to be called red LED pin, and that is on 10. So if we follow that, that's red, and so on. So blue LED is 11. Red sensor pin is analog 0, 1, and 2. So we got those. And then they're saying there's this integer. We're going to call it red value, and it's going to equal 0. Now, Bob Beeman, in my previous video, asked me, do we need to assign that a value? I don't think we do. I think we can just say integer red value. However, I'm not going to waste your time testing it right now. So test it if you want and see if it works there. I believe we can, but because we can just declare that, but then it won't have a placeholder. So I'm not 100% sure in this programming language. Then it's saying, so we've got a red value equals 0, green value. These are just saying setting up integers that we're going to use later. And so I'll get into them later. Okay. Void setup. This is what runs at the beginning. They want a serial port running at 9600 baud. Then they're saying the pin mode on green LED pin, which is number 9. This is going to be an output. Red, which is 10, is going to be an output, and blue, which is 11, is going to be an output. That just means it's putting electricity out rather than letting electricity in to read it like these analog pins would be. Then it starts its void loop where it just keeps running this over and over and over and over. So it's going to, we have red sensor value. So we're just saying, what is the red sensor value? So I believe this was the red one. Oh, it's not named that way anymore. That's weird. It should have saved it. But so we are, if we go up here, we can see it. Red sensor value is, red sensor pin is A0. So this is the red sensor. And they're saying, read red sensor pin. So what is the reading coming off of here? And save it into this integer, this I don't know why I'm not coming up with the right word, but save it into red sensor value. Okay, we have that variable. That's the word I was looking for. Red sensor value is going to be equal to whatever that reading is coming off here in the serial port. I don't know if it's considered a serial port, but the serial reading of that. So some value between 0 and 2000 or whatever it is. And then it's going to wait 5 milliseconds. Okay. The reason why is because things take a little bit of time to do something, right? It's not going to, it says give the ADC a moment to settle. So it's got to settle and save that. Read the value from green. So it's reading red, it's reading green, and it's reading blue. So then it's saving those values. So the current values every 5 milliseconds, right? It's saving those values into red sensor value, green sensor value, and blue sensor value. Then it's printing out those values. So it's going to show you when we run it in a little like monitor type thing. It's going to say raw sensor value, red is, and then it tells us the value, and same for green and blue. All right. Then it says in order to use the values from the sensor for the LED, you need to do some math. We don't need to do math. We need to set up the math, okay? The ADC provides a 10-bit number, but analog write uses 8 bits. You'll want to divide your sensor reading by 4 to keep it in range of the output. And that's just because of how it's set up. So they know that this is how it's set up and that the number will be too big. So we want to divide it by 4. You could divide it by 5. You could divide it by, it doesn't matter. I don't think it matters. We'll get into it. We'll see. So then they're saying red sensor value, which was, up here. It was the direct information from the red sensor pin. Let's divide it by 4 and make that equal to red value. Do the same for green and blue. Then print out that information. Serial print, map sensor value, red is that red value, and so on. Then they want you, now it's time to use post with modulation in the LED. And let me make sure I got all the code. All right. Hopefully that's all the code. Then it's saying analog write. So it's going to write something out. Red LED pin. Now I want you to remember, red LED pin is pin number 10. So it's saying this is not some just some random thing. It's saying pin 10. We could even write 10 here. Okay? We could write 10 there. It's the exact same thing. Okay? So now it's saying pin 10, put the red value out. So it's going to send a post width modulation of a certain amount, which has been defined by this math. Red value, take the red sensor value, divide it by 4, and now we're going to put that amount out into the pin. I guess it was red, so this one. Right? Do the same for the other ones. Green LED pin, which is equal to, green LED pin is equal to pin number 9. Right? And then blue LED pin is 11. And it is going to send out, and this is my educated guess here, because these are red, green, and blue, you can take those colors and create, I believe, every other color. Because they are relative to each other, I don't believe there needs to be any additional math in here because it's going to show red, green, and blue in the same relative scale that it's receiving in the sensors. I hope that makes sense. So like if there was no read and I wanted it to show lavender, I would have to look up the red, green, and blue values that are equivalent to each other. So like I need this much red if I have this much blue and this much green. So we don't have to do that because it's receiving that from the real world. Hope that makes sense. If it doesn't, I can make another video on that to help it make better sense. I know some of my 7th graders that might be over your head. And if it's over your head as an adult, that's okay too. So that's it. And so we should be able to run it. Now we do want our serial monitor showing. So to run it, we want our serial monitor. And then you should be able to just say start simulation. Now I did change that one down here to 10. So we'll see if it works. Now, awesome. So this is putting out our values, which is nice. And I would actually clean that up so it shows up a little bit better. There was an inconsistency between the code. Maybe you caught on. I was busy talking, not paying attention. There was an inconsistency between the code and the programming in this. So actually, these are switched. So what we need to do is we need to look here, and I need to look. I see 11 is connected to red. So if we go here, the red, this needs to be 11. Okay, I'm going to stop my simulator. This needs to be 11. The other pin, this is blue, which is connected to 10. So look for blue and make that 10. And then obviously, we'll double check this though. Green is 9. Green is 9. So now if we run it, and I change my values, it should be correct. So now this one, this connects to A2. We'll see blue is highest, so blue works. If we turn blue down, grab the other one. This middle one was green. We'll see the value is the highest, and now it's green. Let's see if red works this time. So I click and drag. Red went up. It's interesting. These other ones went up too. So I think there's an interference here in the programming, actually. All right. So I figured out what was wrong. It was completely my fault, and maybe you caught it. You didn't have to move these. So if we scroll down to the bottom, I don't know how I missed this. It says green LED pin, blue LED pin, and then I must have written red sensor pin. So if we do red LED pin, and now we start it. So let me start that simulation. Let me get the serial monitor up. Now these values look normal. And as I change my value, oops, the LED lights up correctly. So that was completely my fault. Red LED pin was the mistake there. The way I did it was I compared the original code side by side to mine and then caught it pretty quickly. So yeah, awesome. I hope you learned something, and I'll try to get some more of these done soon. So have a great day, everybody.